Thank you for attending our presentation. I'm Yusuke Hirota, a PhD student at Osaka University. I'll introduce our paper, Quantifying Societal Bias Amplification in Image Captioning. Lately, a lot of works in computer vision have shown that datasets and models contain societal bias. This is a case in, for example, face recognition, in which the models tend to predict black women with higher error rates than white men. Also, models are known to not only perpetuate societal bias, but to amplify it. For example, if the ratio of women to men is 30% to 70%, a model trained on this data can exacerbate that ratio. This phenomenon is called bias amplification. In this work, we examine societal bias in image captioning. Previous work has shown that image captioning models perpetuate societal bias by learning object-gender associations. So far, a variety of metrics have been used to assess societal bias in image captions. One of the metrics is to evaluate whether the gender of the person is correctly predicted. Another metric measures whether the attention activation maps when generating a gender word are located in the person's location. But these metrics have two shortcomings. First, the context of the entire sentence of a caption is not considered. Second, some only measure bias perpetuation but not how models amplify the bias. We propose a metric that measures societal bias amplification of captioning models by analyzing the whole sentence. I introduce our proposed leak metric. For now, let's consider binary gender bias, but leak can be applied to other biased attributes as long as attribute annotations are available. For the image set with gender annotations, we have the set of human captions and set of generated captions by a model. We mask all the gender words, such as man or woman, from the captions. And we train two independent classifiers to predict the gender in the images. The classifiers predict the attributes of the person, such as gender or race, by producing the probability of each attribute, which we call the bias score. For the test set, bias amplification is calculated by comparing the accuracy of the two classifiers. We summarize the leak metric. We basically follow some previous approaches. The point here is that to compute the leak scores, we weight each prediction by the probability of the attributes, which is a bias score. Because bias score can give an extra hint on how much each caption is biased toward the attribute. These leak scores are computed for both human captions and generated captions, and we get bias amplification by subtracting them. Let's move on to the evaluation. We continue with the example of gender bias. We use the Coco validation set with gender annotations and evaluate various captioning models such as Oscar and UPDN. As for the classifiers, we use a simple LSTM. This figure shows captions generated by Oscar with their corresponding binary gender bias scores. The bias score seems to be consistent with human intuition. For example, the second caption from the top has a very high bias score for women, probably due to the stereotype that people who have pink objects tend to be women. We evaluate gender bias of various captioning models. The results show that all the models amplify gender bias. Another finding is that NIC plus equalizer, the model trained with a gender bias mitigation method, amplifies bias. Equalizer is a bias mitigation method to force the model to see people in the image to predict the correct gender and successfully reduce gender misclassification. This result implies that bias mitigation methods should consider the whole context of images. Similarly, we also conducted experiments on binary racial bias. Please check the paper if you are interested in the details. Finally, this is an example of how the equalizer model amplifies gender bias. The baseline NIC generates the correct caption for an image of a woman wearing a white suit, whereas the equalizer generates the incorrect caption, wearing a red dress, associated with the stereotype of a woman. This verifies the need for a metric that considers whole captions. So thank you all for listening. If you are interested, please also check our work on bias in visual question answering dataset. Thank you.